next few weeks, we are going to do nothing but look at lines. Do you all feel like you're understanding what lines look like as an equation and what lines look like as a picture? Okay? Now we're going to begin describing lines. And we are going to describe lines in two different ways. We're going to describe lines by how steep and which direction, which is called slope. We're going to work on this for the next 2 class periods prior to the quiz. And then after Thanksgiving break, we're going to work on the initial value, meaning where it crosses the y-axis. And so as we start looking at all things about lines, we're going to say, hey, which way is it trending? Is it going up or is it going down? Is it steep or is it not very steep? What does that look like? I want you to hear that a line has a slope of 4 and immediately be able to envision what it will look like. Not necessarily on graph paper, but no, oh, that's really steep. Or, oh, this has a slope of negative 1/15. Oh, that's really flat. And have those ideas already visualized because we've worked with them so much. And then we're going to talk about initial values. And initial values are where it's crossing the y-axis when x is 0. Those are the 2 most important things you got to know as we begin working with lines. So let's talk about the slope. The slope of a line tells us the direction and the steepness of a line, okay? This should not be new. I'm teaching regular 7th grade math right now to your friends that are not in advance. And for this whole entire week, we're talking nothing about except this word. So you all should be remembering the basics of slope from last year. And I'm going to teach you the pre-algebra version of slope. If you don't remember any of the basics, you're going to have lots of work to do. And you're going to need to pay really good attention to make sure you're processing really well. Or you're going to be very confused. Okay? Slope describes the steepness and the direction. And there are 4 types pictured here. You may need to have this in front of you if you feel like you're behind. Okay? I've been trying to preview that for you by talking about the lines when I said, hey, would you describe this line as increasing or decreasing? And everybody said this first one would be increasing. And an increasing line is a positive slope. So when we look at pictures, when I say, hey, this one has a positive slope, if you get a picture that looks like this, and I told you it needs to be a positive slope, you should say, oh, I got something wrong. Because positive slopes should be going up. And negative slopes then should be going down. And a 0 slope is one that creates a horizontal line. And this has 0 slope because there is no rise in the line. Okay? Verbal description of slope that you should know from 6th and maybe even 5th grade is rise over run. Y over X. That's what we're analyzing anytime we talk about slope. A horizontal line like the floor in your bedroom or the floor in our classroom is not rising at all, and that's a good thing. I don't want to come in my classroom and have to walk uphill. I don't want to put something on the ground and have it roll because the floor is not flat. Okay? A vertical line then is called undefined, and it is undefined because there is no run. So if we're talking rise over run, 0 slopes don't rise at all, they go running, but undefined slopes don't run at all, which puts a 0 on the bottom, and a 0 on the bottom of a ratio or a fraction is undefined. Hopefully you've all typed in your calculator 12 divided by 0 before. And it gives your answer arrow. Error, not arrow. Thinking of graphing. It's error because you cannot divide a number into 0 groups. Okay? So those are the 4 basic types of slope. You should be pretty familiar with dealing with them on a graph. If you're not, I'm going to give you the condensed version of 3 days of lessons in 7th grade before we go to the back and I teach you the algebraic version. Before we start that, I use this little guy up here on the wall that I'm going to show you to help my 7th grade class remember the types. This is called Slope Man. He doesn't look very happy, but he is Slope Man. One of his eyes is a positive slope. And one of his eyes is a negative slope. Does everybody see the positive going up and the negative coming down? His nose is a vertical line, which is what kind of slope? Undefined. And his mouth is horizontal, which has a slope of 0. If your brain remembers pictures, sketch that picture in your note. And when you're studying for that quiz next Monday, make sure you know what the 4 types of slopes are going to look like. Slope can be given in lots of ways. Our preferred way in this class is going to be looking at slope as a fraction. We are going to be writing the fraction version of slope 99% of the time. We will use the verbal description whenever we're doing word problems. Okay? I don't love decimal. I'm not saying you can't do it, but we are never going to change the slope on a coordinate plane to a decimal. We are always going to leave it as a fraction. The only time I ever turn it into a decimal is if I'm needing it for a word problem. And you'll see an example here in a second. Let's look specifically at graphs for let me turn that off. For 1 and 2. And I'm going to enlarge this a little bit. Okay, 1 and 2. First question. Which one of these is discrete? Which graph is discrete? What do you think? Everybody here should know that. It's on the quiz next week. Cooper? 1 is discrete because they're not connected. Why are they not connected? I know they're dots. Why are they not connected? What is this talking about? Lunches. Can you buy 1.72 lunches? No, you buy 1 lunch, or you buy 2 lunch, or you buy 3 lunches. It's still linear. Would you describe this situation as a positive slope or a negative slope?
Positive.
Positive. It's going up. Would you agree?
Yeah.
This one is continuous. Why is it continuous? Can you tell me how many pages you've read in 3.5 minutes?
Yeah.
Is there such thing as 3 minutes and 45 seconds?
Yeah.
3 minutes and 50 seconds?
Yeah.
So that's why it's continuous. Positive or negative?
Positive.
Positive. In both of these, as the x goes up, the y goes up. More lunches, more cost. More minutes, more pages. Who's going up faster, would you say? Which line is steeper, 1 or 2? 1. So we understand what steepness is looking like. Okay? When you're on a graph and you need to find the steepness or the slope, you simply pick a point. I'm always going to pick probably the first point on the left, which in this case is 0, 0. And you're going to draw a little arrow up. Draw that arrow up. How many units did I go up? Don't say 2. 6. I know why you want to say 2. If you're on a coordinate plane, you can say 1, 2, 3, 4. But if you're in a real world problem, you got to read the labels. I went up 6. Does everybody agree? How many do I go over till I hit the next point? 1. That means my slope is 6 over 1. Now, this is when some kids like, Miss Kearns, I did different points, and I got a different answer. And I'm going to say, okay. Oh, I better pick a different color. Let's pick black. I'm going to start here at 0, 0, and I'm going to go all the way up here. So I'm going to go up how many? Up 30, and I'm going to go over 5. What is 30 over 5? 6 over 1. Did I get the same slope even though I did different points?
Yeah.
And if you count correctly, you can get different numbers, but they should all reduce to the same thing. What would the decimal be of 6? It would just be 6. And the verbal, this is where you have to use the labels. What does that slope 6 mean? It means 6 lunches, x. No, that's not true. I said that wrong. It means $6, the Y label, over one lunch. $6 per lunch, or 30, that's a typo. 30 over 5 lunches. That's a typo. Not one kid's pointed that out. This should say 30 over 5. Right? It was 30 for 5. Is that making sense? Let's go on to number 2. When you get this on your IXL in the next week or two, I get lots of kids that text me or email. Nobody texts me. Nobody has my cell number, but people email me. I just always say text. Ms. Kearns, there's no points on the graph. What do we do? Do you understand that this line is made up of nothing but points? And so if there's no points on the line, your job is to make some. Make a point. Oh, I hope my Apple Pencil will work. Make a point. Of course not. Wherever you want to make a point. You can go clear up here. You can go right here. What I would not do, and I wish I could get this to enlarge so I could write on it. I would not do this point. Again, that is a point that you can't see because it's not there. I drew it right here. That is a point on the line, but I'm not going to use it. Why? Well, I don't really know where it is. When you put your points on the line, you want to put points that you can clearly visualize and see. Okay? Let me shrink that out there a little bit. So, I'm going to do what I did last time. I'm going to start at 0, 0, and I'm going to travel up how many units? 2 boxes, but it's really 3 units. And to hit the line, I'm going to have to go over 2. So what would my slope be? 3 over 2. Now, this is where you can make it a decimal. You're never going to give me the decimal form. I'm counting the decimal form wrong unless you're using it in a word problem scenario. But what would the decimal be? 1.5. So this slope, even though it's a fraction, is more than 1. Every time I get kids like, oh, my slope was a fraction. Just because it's a fraction doesn't mean it's not more than 1. Do we all follow? Mm-hmm. And what would my verbal representation be? 3 pages for 2 minutes, which doesn't tell me a lot, which is why you might use the decimal. I'm doing 1.5 pages every minute. I'm doing 15 pages every 10 minutes. That's that point up there. With that, yes?
I just wrote 3 pages per 2 minutes.
Okay, if it asks, though, for what you're reading every page, if it ever said, what am I reading per minute, you would need to be able to calculate that. Okay, it's fine. Look at number 3, read that scenario, and see if you can figure out which graph would represent that scenario based on the babysitting information there. Brittany babysits 7 hours and earns $105, which has a slope that best represents the average rate she's making per hour. First of all, is Brittany making any money when she doesn't work? No. I'm trying to find out if she's making how much per hour. I would say, well, it needs to start at 0, 0, which automatically means D's off the charts. This says at no hours she makes $105. That'd be great. She's not making $105 just for showing up and staying till the people get home. She's making $105 for 7 hours, which means she would make different money for 8 hours and different money for 6 hours. So then you have to say, okay, well, which one of these graphs, A, B, or C, would have the point at 7 hours making $105? Where am I hitting 7 hours at 105? Graph C. We all follow? All right. So that is plotting points, finding the graph. We're going to do some more of that at the end of notes today, counting. But what we're going to do now is say, can you find the slope without a picture? I'm going to show it to you with a picture and show you how to do it without a picture using what we call the slope formula, which is not letting me write with that right now, so I'll try to pick up a pen and circle it for you. The slope formula. M is what we call the universal letter for slope. You will see M used from now until calculus. Now some kids are like, what do you mean M? Well, think about L. What does L always mean? Length. What does W always mean? Width. What does R always mean? Radius. Right? You notice M in mathematics stands for the slope, which is the ratio of y over x. Every time I introduce this formula, I get lots of kids like, oh my gosh, there's these exponents that are at the bottom. Those are not exponents. Exponents are in the top. These are called subscripts. And what they are saying is that you take the two y's, the second y minus the first y. And then you take the second x minus the first x. That means you are looking at the change in y over the change in x. Okay? I'm going to show you with the graph, and then I'm going to show you with the formula, and I'm going to try to teach you to use the formula because honestly the formula is faster, more efficient, and you don't need graph paper. If this was the graph and I said let's count the slope, ignore the red there, that's showing you the formula. I would start here at 2, and I would go up here, and I would say how many am I rising? From 2 to 7 is rising 5. Does everybody get that? And how much am I running? Wow, I wrote 5. It disappeared. How much am I running? From right here to here is 4. Again, I'm not going to make it 1.25. The slope of this line is 5/4. Everybody agree? So say I covered that up and I didn't give you that picture, or I just gave you some points. Let me show you how to use the formula. The formula says pick any 2 points on the graph. I'm going to pick x1 to be that purple dot that I wrote all over. I'm going to erase everything that I wrote so you can see it better. So to do this, you pick any 2 points just like we did to count it. And you're going to call one of them x1 and you're going to call one of them x2. It doesn't really matter which one's which. It just means point 1, point 2. And they can be in any order. And then according to this formula, it says take the second one and subtract the first one and do the y's first. What is the second y? 7 is the second y. What's the first y? 2. So you would have 7 minus 2, which is 5. Then it says go back to the second. This is the number one mistake. I get a lot of kids that want to do 7 minus 2, and then they want to do 0 minus 4. That will get you the wrong sign every time. You'll have the right number, but you'll have the wrong sign. You've got to go in the same order. So you're going to have 7 minus 2, and then you're going to have 4 minus 0, which means my slope would be 5/4. Is that what we got when we counted? Yeah. So the whole point of this formula says, hey, you really don't need a picture. That's kind of elementary. All you really care about is how are the y's changing? How are the x's changing? Okay? Let's look at a table. If you get a table of values, all I need is 2 points. Before this year, I would give my kids a table. I would hand them some graph paper. I would say, plot all those points, and then start making your stair steps. Does that make sense? We are ready for algebra. Let's look at our table and pick any 2 points. We're going to pick these 2. You can pick any. I'm just picking those 2 random. Okay? When you take the quiz and I give you a table, pick any that you want. And then you're going to say, okay, I wrote x2 up here. Oh, it's there. It's just not showing up. What is the second x? No. What is the second y value? -3. Does everybody agree? So if I'm writing this on my paper, I'm going to write -3 minus the first y value, which would be 0. That's going to be the math problem. Over, it's got to be a fraction, y's over x's. If you study nothing tonight, you've got to study that it is y over x, which is kind of opposite than the ordered pair xy. Do we all follow? Negative 3 minus 0 is going to give me what? Negative 3. And 1 minus negative 1 is going to give me 2. Negative 3, 2. Yes.
So x2 goes first.
Second minus the first. And honestly, this is what I don't love about this formula, because people they're like, I did it in a different order. Do you all follow that if I did 0 minus 3 first, I would have gotten positive 3, and negative 1 minus 1 would have added the opposite over negative 2. And is negative 3 over positive 2 the same thing as positive 3 over negative 2? Yes, because if you have one negative, the answer is, does it matter if the negative's in the numerator or the denominator? One negative, no matter where it's at, is the same. So your question is this one always second? It doesn't matter which one you call second as long as you call it second the whole time. Okay, and I'll show you an example of that. You try 5 by yourself. See if you can figure out what 5 looks like by yourself. You can pick any points you would like. Hey, B, you need to wake up and look up and not be sleeping. Yep, you were. Promise. I picked the first two. Do I care if you didn't pick the first two? No. But I just usually start at the top. What is 140 minus 90? 50. And what is 2 minus 1? 1. No matter which ones you picked, you should have ended up with 50. Now, if you picked this one and this one, you would have ended up with 290 minus 190. What's that? 100. 5 minus 3. What's 100 divided by 2? 50. Does it matter what you pick? Just like it doesn't matter what you count. What if I only give you 2? What if I only give you 2? Does it matter that you only have 2? Pick whichever one you want to be second. I'm going to call the purple one second. I'm going to prove to you, though, that it doesn't matter. What are you stuck on, Alexis?
I have a negative.
You did what I said. You went 140 minus 90, and then you went 1 minus 2. Got to go in the same order. No negative there. Right?
This was for x1 and then this was for
Right, so you should have done this way, and then you should have done this way. What you did is the most common mistake. You went up, and then you went down. You can't do that. You got to go in the same order. Okay, I'm picking 9 as my second, so I'm going to have 9 minus 7. Everybody agree? And then I'm going to go back and get 5, what she had a negative for. You get the same numbers, just the wrong sign. If you go 9 minus 7 and then 12 minus 5, that's going to be wrong. Got to go back to whichever one you started with. If you had said, oh, I don't want to start that way, I want to start this way. I want to start with this one. I want to do 7 minus 9. Okay. 7 minus 9 gives me 12 minus 5. Here I would get negative 2 over 7. Whereas down here I get, oh, it's not coming in, but it's almost there. Here I get 2 over negative 7. Up here, it's on the screen, on my screen, I promise. You get negative 2 over positive 7. Does it matter where the negative is? No, this final answer here then would be negative 2 7ths. It's coming up on the screen, I promise. If you looked at a picture of this graph, which way would the slope be going? Can you all visualize that with me? The slope would be going down. Why would the slope be going down? Because I have a negative slope. Those are the kind of things you have to start analyzing so that when you take the test and you're like, oh, I got a negative slope. And oh, I got a picture going up. Uh-oh. Sort of like when you draw the mountain range when you know it's supposed to be a line. I've messed up. What did I do? I got to fix it. Does that make sense? You try 7 by yourself. You try 7 by yourself. What did you do in MTSS? You didn't do any IXL skills during MTSS. How come? What did you do?
I submitted my assignment, and then Miss Harrison was talking to me.
Okay, gotta make sure you're doing those, right? I'm able to like look at my class and just see like what people worked on, and I was looking for somebody else, but I was like, what? Like anybody who wasn't here, obviously they don't have any work on it, but everybody's here should have it. That's what you're supposed to do on Tuesday. Let's work on those. There's another person that didn't do any. Thought I need to see you after class too. Okay. Oh, he's not in here.
Yeah, no.
He turned his in, but he's done no work today. So obviously he's figured out a workaround sheet. So we'll work on that. Let's look at number 7. Number 7 says a line passes through the given points. 8, -3, and 4, -3. Hopefully you started this and said something like, I'm going to get -3 minus -3. What is that going to give me? 0. Do I care what it's over? No, this is clearly going to be a line that has a slope of 0. What is that going to look like? Horizontal. It's not going to look undefined. It's going to look horizontal. 0 in the numerator is 0. 0 in the denominator is undefined. You try 8. You try 8 right now. Wrong. He took it in under a different number. That makes me feel better. That's probably what he was doing during MTSS today. Oh, that makes me feel so much better. We following the pattern here. We're going to have, I'm going to write mine as, well, I'm going to go with what this is up here. Again, that's not the only way to set it up. Have I convinced you of that? You could have, oh, you don't have it up there yet. 6 minus 10, -5 minus 3. Work on your order of operations and that. If you get a -4 over a -2, what does that mean this slope would be? +2. It's really important that you guys get that concept down so that you understand this would be a line that's going up. Before we start number 9, let's look at it and think about it. What is happening when both of those x values are 6? Where does that mean that's going to be? That's going to be vertical. Why? Because you're going to have 6 minus 6 on the bottom. Are we following? You can do 13 minus negative 8, or you can do negative 8 minus 13. But either way, you're going to have 6 minus 6. And whenever you have that happening, 6 minus 6 results in a 0 in the denominator, which is undefined. Okay? All right, we've learned lots of ways to look at things. We've looked at them in tables, we've looked at them in graphs, and we've looked at them in ordered pairs. Using that info, I want you to try to answer which slope is decreasing the fastest based on 3 different forms. It's easy to compare money if it's all dollar bills. It's easy to compare money if it's all quarters. But if you have some quarters, some dimes, some dollar bills, and you have to compare them, then you've got to get them all into their value. So the first thing you probably need to do, this is not your homework. This is something we're going to do an activity with for the last few minutes. We're going to use graph paper in here in our notes this rest of this unit. And this is just going to stay in your notebook so that when I'm like, hey, get out some graph paper, everybody's got these little mini graphs to work from today. Okay?
What section is it?
A lot of kids have their own, but then it takes forever for them to draw the coordinate plane. So this is just like, hey, go to a graph. Hey, go to a graph. Everybody doing number 10 right now. Don't put your notes away. We're going to use them. You're going to need your notes. We're going to be referencing those. Did you not get one? Oh. They're right there. All right, let's figure it out. Got to find the slope of each one. Does everybody agree for A? I would be going down 3 and right 4. This would be an M of negative 3/4. Yay or nay? Going down, negative slope. If anybody had a positive slope there, that should have been a clue that you made a mistake. For B, any 2 points, I'm just going to pick these two. I'm going to do 8 minus 7. And I'm going to do negative 2 minus 0, which is going to give me 1 over negative 2. You might have done different points, but we all should have gotten M is negative 1/2. Who is going down faster between A and B? Negative 3/4 or negative 1/2?
Negative 3/4.
Negative 3/4 is faster than negative 1/2, because this would be 0.75 and this would be 0.5. Does everybody agree? All right, let's look at C. I would have 18 minus 10. I always go with the first one first, but you could have done 10 minus 18, as long as you keep it in the right order. And I have 6 minus 8. 8 over negative 2, which is negative 4. Who is clearly going down the fastest? C is going down the fastest. There you had to put it all together. Use all three forms to make that comparison. Let's look at your graph paper that I've given you there. So we are going to just do lots of little practice before I give you your assignment so you're not confused. And so I'll just say, hey, grab a graph. Grab any graph you want and work on it. And then I'll say, hey, put this on the same graph, or I'll say, go to a new graph. Here's what I want you to do first. I want you to plot 4, 5 as point A, and I want you to graph negative 2, negative 4 as point B, and I want you to stop.
Oh, mine's upside down.
Find a graph. Yeah, put the graph holes, the hole punch on the left. Can everybody plot those 2 points? 4, 5 would be right here. Make sure you label it A. And B at negative 2, negative 4 would be down here. B, are we all on the same page? Yay or nay? What quadrant is A in? And what quadrant is B in? And what do I name those with? Roman numerals. Let's connect A and B. Take your straight edge and connect those. Would this line have a positive slope or a negative slope? Positive. Let's count it. Oh, sorry. Oh, come on. Let me get the pin out. Well, I'm hoping it'll let me get the pin out. Oh. I'm going to go from B to A. Do we all agree? So I'm going to go up how many boxes? I'm pretty sure that's up 9. And I'm going to go over 6. M would be 9 of rise. You don't have to write that. I'm just writing it to help us remember. And a 6 of run. Do you think I can leave my answer 9, 6? No. What would I need to do for my answer here? Simplify, which would reduce to 3 2's, which means, let's go back to point B. Put your pencil on B, and let's go up 3 boxes and over 2 boxes. Did I hit the line? And from there, I could go up 3 and over 2 more. And up 3 and over 2 more. So the biggest thing I want us to see is it doesn't matter which set of points you use. As long as you reduce it, you're always going to get to the correct answer. More so, we could use the formula. What would the formula be? 5 minus negative 4 over 4 minus negative 2. What's 5 minus negative 4? 9 over 6. And what would you do with that? Reduce it. Whether you use the formula or you count, you get the same answer. Have I convinced you? Here's what I want you to plot now. C is at negative 2, 6. And D is at 4, negative 1.
On the same graph?
New graph. We'll do some on the same graph in a minute. -2, 6 would be in the second quadrant. Do we all agree? C. And D is at 4, -1. Fourth quadrant. If I connect these two, what kind of line am I going to get? A decreasing line. Find the slope of this line once you've drawn it. M equals. I don't care if you count it or you subtract it. Use whatever method makes sense to your brain. I'm a counter. I hope you're all realizing if you're going down, you should start on the left. Always start on the left. Nobody should be counting up right now because this is clearly going down, which means it is -7. How many is it over? 6. Everybody's favorite numbers. Again, don't make that 1 and 1/6. It's always got to be a rise number. And I know it sounds weird to say rise, but the rise is going down. And a run number. Always start on the left. Yay? I don't like kids that do this. I get some kids that want to do this. I don't like that. That gets confusing. I also don't like kids who want to go, oh, I'm going to go over first and then down, because then you forget to put this number has to be on top. Does that make sense? All right, before we do the last one, I want to go back and ask you a question about this line. Maybe. This has a slope of 3/2. Is that a slope of more than 1 or less than 1? More than 1. Do we all agree? If I said from this point, tell me a slope that would be a steeper line, could you do it? So I want to draw a line that would be steeper than the blue one. What would be a slope that would be steeper? Instead of going up 3/2, what would I need to do?
Go forward.
Okay?
And then go across 2.
Okay. That'd be fairly steeper.
Go 4 over 1.
If I went up 4, oh no, right here, and over 1, does everybody get that that line would be a lot steeper? Because 4 is bigger than 3/2. 4/2 would have been steeper, but it's only 2, which is only a little bit bigger than 1.5. Can you guys give me a slope that is flatter? Go up 1 and over 5, 4, any over here, that'd be way flatter. The bigger the number, the steeper. Smaller the number, flatter. Last one, new graph. Let's plot this point at, let's see, this is point E, at -2, -4. E. New graph. So far. Now, instead of giving you the point, I'm going to give you M. M is 1/4. So if you know what M means, rise, run, you should be able to give me another point. I'm going to go up 1 and over 4. Where would I be? 2. Now, I get a lot of kids that do this step thing. I don't care if you drag your step, but you're not drawing triangles and you're not drawing steps. You can drag your pencil, but don't make your pencil be a bunch of stair steps. Or don't make your graph be a bunch of stair steps. Now, how many points do we have to graph? How many in the tables?
4.
How many points did we do in all the tables? 5. So you really should try to do this 5 times if it will fit. How do I do the next one? I start at the point I was at, and I go up a box and over 4. Up 1, over 4. I'm out of room this way. And my teacher said I have to try to get 5. What other option would there be? I could go back to E and do the reverse. What would the reverse be? Down 1 and left 4. And I would get a really, really flat line that is positive. Should it be positive? Was my slope positive? Yes. My graph is smaller because my graph only goes to 6s and your guys' go to 8. So that's why your picture looks a little different. Should still be flat like mine. It's just not all the way at your edges. Okay, last one. I know I said that was the last one, but let's try this one. F. -2, 5. Same graph, different color for me, but you can do it on the same color. -2, 5 would be up here in quadrant 2. Do we all agree? Okay, I'm going to see who's got big brains here. M is -2. You try. We'll see who gets it right. Should my line be going up, down, flat, or vertical? It better be going down. So if you're getting one that's going up, if you're getting one that's vertical, What? What? There is no, you're supposed to be graphing it. There's no getting something. F is there. Tell me if it's rise over run. What does that mean the rise is? Down 2. And what does that mean the run is? Don't say 0. The run is 1. Put your pencil on F and count down 2 boxes and write 1. And down 2 boxes and write 1. Down 2, write 1. Are you following how you can graph? Is that picture in orange clearly negative? All the way across the graph. Yeah, eventually we're going to start looking at putting multiples on a graph and where they touch, but that's a different lesson. But that's a good preview for it. Today's assignment is assignment 39. It's on slope, day 1.